Well, students, having done refraction from plane surface, now we'll enter into refraction from spherical surfaces. Before we enter into refraction from spherical surfaces, again, we have to be familiar with certain basic words which are related with it. Now, in IIT syllabus, we are going to deal with spherical surfaces only. We may have other type of surfaces like cylindrical, parabolic or of other geometries, but they are not of any interest to us. In IIT JEE and other entrance examination, we always deal with spherical curved surfaces. Now, any curved surface or any interface which is a part of sphere can be taken as spherical refracting surface. As in case of a reflection from curved surfaces, we dealt exclusively with spherical mirrors. Here also, we are going to classify spherical refracting surfaces into two basic categories, that is concave and convex, as we have done in case of spherical reflecting surfaces. Now, in case of mirrors, it was very easy to decide whether the reflecting surface is concave or convex. There the criteria was very simple. In case of convex mirror, the central part was raised, whereas in case of concave mirror, the central part was depressed. But here, the mediums are transparent, rays travelling from one medium to another medium. A surface looked from one medium may be concave and from other medium it will be convex or vice versa. So, we decide a very simple point, that is the nomenclature of spherical refracting surface is decided by looking at the interface from a rarer medium. I repeat it, the nomenclature, that is whether it is a concave spherical refracting surface or convex spherical refracting surface, is decided by looking at surface from a rarer medium. Say for example, if you just concentrate on the figure coming on the screen, now let's say the first medium is having refractive index mu1 and the other is having refractive index mu2. Further, let's say mu1 is less than mu2. Obviously, if I look at the surface from first medium, it appears convex to us. So we are going to name it as convex spherical refracting surface. Now, there are certain other terms related with it. The first is the radius of curvature. Again, the radius of curvature of refracting surface is the radius of sphere of which spherical refracting surface is a part. Then we have center of curvature. Center of curvature, which we are going to denote it by C, is the center of sphere of which spherical refracting surface is a part. Similarly, pole. In case of a convex spherical refracting surface, pole will be the most raised point. Whereas in case of concave spherical refracting surface, pole of the surface will be the most depressed point. Similarly, we have principal axis. The line joining pole and center of curvature of the surface is referred as principal axis. Then we move to the next word which is used in connection with spherical refracting surface is aperture. Now this is similar to the definition of aperture as we have used in connection with mirror. Aperture is the diameter of the circular outline of the spherical refracting surface. Obviously, this aperture indicates the size of spherical refracting surface. The more the aperture, the more is the size of spherical refracting surface. Now, it is also obvious that the maximum value of aperture will be equal to diameter of the spherical refracting surface. If I say r is the radius of curvature of the spherical refracting surface, then aperture, which I am denoting it by small d, that is the diameter of the circular outline of a spherical refracting surface, will have maximum value equal to 2r. Now these are the words which we will be using in connection with spherical refracting